So let's say f of x squared minus 1, x squared minus 3x plus 2. So they're asking us to determine everything. And graph the function, plus graph. I'm going to get my table going. The prime, the function in the middle, and f double prime, second derivative. When we look at this function, what is the first thing that comes to mind? Of course, I have to find the domain. So what is my first thing that I need to perform? For sure. What will be the first step here?
Find the domain.
Excellent. And in order to find the domain, what will be my first step?
Set the denominator equal to 0.
Perfect. In other words, factor and simplify. Always, these are the keywords in math. Good, so I see the numerator can be factored, the denominator can be factored, and how do I do it? Can anyone give us the factored form?
X minus 1, x plus 1.
Good.
X minus 2 is x minus 1.
So x minus 2 and x minus 1. We agree with that? Everyone? Yes? So where is this function undefined then?
At x equals 1 and x equals 2.
Thank you very much. If you use the table and you show me this, you don't have to write anything else about the domain. Now let's take a look at the entire function. Is there anything we can do here? Anything? Any suggestions?
You mean, is there anything else we could do?
Victoria, can you say it again?
Define the x and y intercept.
Nope. We look at the function first. And we must notice something that's absolutely crucial. What do we notice by looking at it? By inspection. By visual inspection, what do we conclude? Do we notice anything here?
Two of the factors cancel.
Good. So x minus 1 goes away. I immediately write under 1, whole, not vertical asymptote. So the simplified form of this function is x plus 1 over x minus 2. And I know that x equals 2 is a vertical asymptote. After that, I will have to find this limit. I will have to find what happens at 0. I will have to find limits left and right of 1, limits left and right of 2, and this limit. 1, 2, 3, 4, 5, 6, 7, plus where this is 0. 8. Can anyone give us this limit? The limit as x approaches infinity or negative infinity of x plus 1 over x minus 2. Do we have an answer for this? You can say infinity over infinity, differentiate, and tell me the limit.
1.
1. It's a rational function. There is a guarantee that if this is 1, this will be 1, which means y equals 1 is a horizontal asymptote. Y equals 1, horizontal asymptote, so I don't forget. Now let's plug in 0 and see what we get. When we plug in 0, what do we get?
Minus 1 over 2.
Very good. Awesome. Good. And now when is this function 0? When is a fraction 0?
X equals 2.
That's undefined.
X equals negative 1.
Yes, when x plus 1 is 0 or x equals negative 1. Awesome. Immediately put it in the table. All I need now are these limits. And then I can move on to the first derivative and the second derivative. Okay, so limit of this to the left of 1, limit of this to the right of 1, limit of this to the left of 2, limit of this to the right of 2. I already know that these have to be infinities, but I don't know the sign. Okay, then. So limit as x approaches 1 from the left of x plus 1 over x minus 2. Limit as x approaches 1 from the right, x plus 1 over x minus 2. Can anyone give us these limits? Can anyone give us this limit and this limit? They have to be the same. It's a whole.
Negative 2.
Yes, so the top is 2, the denominator is negative 1, so it's indeed negative 2. I found something, I found something, I found something. Good. So now can anyone tell us, so the numerator is positive, the denominator is 0. The numerator is positive and the denominator is 0. So these, remember, a number over 0, negative infinity, positive infinity, or DNE. There's no hope. So what do I write? 2 from the left is 1.9. 2 from the right is 2.1. Can anyone give us these? I know you know.
DNE.
I can write DNE if it's an oscillated limit. It's a rational function. So this cannot be oscillating from the left or from the right. Right?
Infinity.
We already know that it has to be infinity because this is a vertical asymptote. What we don't know is the sign. Now, if we talk about from either side, in this case, it will be DNE. but we only need from the left and from the right. So from the left, we plug in 1.9. What do I write?
Negative infinity.
Perfect,
Negative.
awesome, yes, awesome. From
And
the
then
right,
positive.
exactly, that's all I needed. So it's negative here and positive here. We exhausted the function. There is nothing else I can find out. I have limits at infinities. I have limits left and right of the asymptotes. I have the whole. I have the x and y intercepts. I exhausted the function. It's done. Now I can move on to the first derivative. Finally. So f prime. So this is the function. Top prime is 1 times the denominator minus top x plus 1, don't forget parentheses because it's minus, times the denominator prime, which is 1, over x minus 2 squared. So x minus 2 minus 1, so negative 3 over x minus 2 squared. Never 0 and never undefined where the function is defined. It's undefined at 2, but so is the function. So because it's never 0, there are no critical numbers. What is the sign? I need the sign of this now so I can put it in. And of course, you're not going to check the sign of x squared plus minus 2 squared. It would be a waste of time. So what is the sign? Can anyone tell me the sign of this expression?
Negative.
Good. At this point, I need to make sure that these two rows work well together. If they don't, I'll say oops and start from scratch. I hope that's never the case. From 1 to 0, yeah, that's correct. And it's supported by the sign. From 0 to negative, yes, 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 yes. So this is okay. Now I will move on to the second derivative. So the second derivative. So I'll change this into x minus 2 to negative 2. So I have 6, x minus 2 to negative 3, times the inner function prime, which is 1. So this is 6 over x minus 2 to the third power. Which will, I will write it at least in my head, if not in writing. I will write it like this, because I know that this is never going to hurt anyone. It's always positive. Again, never 0, never undefined where the function is defined. I need the sign. I'm not going to waste my time with this, and I'm not going to waste my time with this. But this gives the sign. It's 0 at 2. So can you plug in a number before 2 so I can put the sign in here?
Negative.
Yes. And can you plug in a number to the right of 2 and tell me the sign?
Positive.
Excellent. That's it. Nothing else matters. Who cares? All I need is this. Nothing else. When I graph a function with asymptotes, I have to graph the asymptotes first. They're not part of the graph, but they have to be graphed. And I see a 2. And I see a 1. And then I plot negative 1, 0, 0, negative 1 half, 1, negative 2, opening down, decreasing from 1, crossing the x-axis, crossing the y-axis, going through this hole, 1 comma negative 2, approaching negative infinity, always concave down, always decreasing. Not touching the asymptotes. We may say eventually. Good. On the other side, from positive infinity down to 1, opening up, always decreasing. So this is the function, the original function, not simplified, x squared minus 1 over x squared minus 3x plus 2. Any questions on this? Any questions? Anyone, any questions? The only one thing, and the last thing I want to mention here are, so we know how to determine a horizontal asymptote by determining the limits at infinity. We know how to determine a vertical asymptote, determining the limits left and right. The only thing that I want to talk about, the last thing, is the slant asymptote. Which rational function has a slant asymptote? Degree n plus 1 and degree n. So, for example, x squared over x plus 1. Degree 2, degree 1. Or degree 1 and 1 more. X to the 4th over x plus 1 does not have a slant asymptote. It does not fit this model. The degree here is 1, and the degree at the top is not 1 plus 1. Degree 10 and degree 9. This fits the slant asymptote. See what happens here. The division, when I divide these two, I get a line. When I divide degree 10 by degree 9, I would get a line. But when I divide degree 4 by degree 1, I will get degree 3. I will not get degree 1. So the numerator has to have 1 more than the denominator when it comes to the degree. 4, 5, 6, 7, 9, 10. 4, 1 doesn't work. So the numerator, 1 more degree than the denominator. And let's just refresh our memory on how to find the slant asymptote. Where are those? Okay, here's an example. We're not going to go through all. We don't have time, so we're going to choose any, and we will determine. But right now, I want to choose one to find the slant asymptote. Just the slant asymptote, and then we'll stop. I know I have 5 minutes. I can determine the slant asymptote in 5 minutes. So let's choose. So see, degree 3, degree 2. Yes, slant asymptote. Degree 2, degree 1. Yes, slant asymptote. 3 and 2. Yes. This, I don't know. It's an exponential, so I have to see where this is going. It's a different story here. Okay, I'll choose 70 just to determine the slant asymptote. Y equals 1 plus 5x minus 2x squared divided by x minus 2. So we have two possibilities here because the denominator is x minus a. If it's x plus 5, then a equals negative 5. If it's x minus 1, then a is 1. Here it's x minus a, where a is 2. because the denominator looks like this, we can use the synthetic or long division. If the denominator is x squared minus 3x plus 1, only long division. But if the denominator is x minus a number or x plus a number, we can use the synthetic or long. Which one you prefer?